From the earliest moments of human evolution, our hands have been more than mere appendages, they have been tools, symbols, and instruments of survival. Even in the prehistoric wilderness, every movement mattered. Picking up a stone, grasping a branch, or wielding a primitive tool was a decision that could mean life or death. Among these small yet vital choices, humans developed preferences for one hand over the other. These preferences were not random, they were shaped by the brain, the body, and the demands of the environment. Across thousands of generations, a subtle yet profound pattern emerged. The right hand became dominant in the majority of humans. The dominance of the right hand is not merely a habit, it is rooted in the very wiring of the human brain. In most individuals, the left hemisphere of the brain controls the right side of the body, and it is specialized for sequential thinking, language and fine motor coordination. This neural configuration allowed early humans to perform precise tasks efficiently. A right-handed hominin could chip stones into sharp tools, hold weapons with stability, and manipulate objects with consistency. Precision mattered when hunting animals or preparing food. A slight slip could lead to injury or missed opportunity. Evolution naturally favored those whose dominant hand aligned with the majority neural pattern, reinforcing right-handed preference over millennia. Yet evolution never eliminates variation entirely. Even as right-handedness became more common, left-handed individuals persisted. This persistence was not an accident. Across generations, left-handedness carried unique advantages. In certain contexts, combat, hunting, or novel problem-solving, the unpredictable movements of a left-handed individual could disrupt enemies, outsmart competitors, and provide unexpected solutions. Evolution preserved this minority trait because diversity enhances survival. A group entirely composed of right-hand dominant individuals might be efficient, but it would be vulnerable to disruption. Left-handed individuals introduced flexibility into the system, balancing predictability with unpredictability. The earliest archaeological evidence of handedness provides fascinating insight. Cave paintings, stone tools, and skeletal remains suggest that humans were predominantly right-handed even tens of thousands of years ago. For example, wear patterns on teeth, bones, and tools indicate consistent hand preference. Even prehistoric artwork, from hand stencils in caves to intricate carvings, shows a clear bias toward right-handed execution. Anthropologists have noted that approximately 9 out of 10 ancient humans favored the right hand, a ratio remarkably consistent with modern populations. This continuity suggests that the forces shaping handedness, neural architecture, environmental demands, and social coordination, have been operating for tens of thousands of years. Handedness is not merely a physical trait, it carries social and cultural significance. In early human societies, group cohesion was essential. Coordination in hunting, defense, and communal tasks depended on predictable behavior. Right-handedness allowed groups to develop standardized tools and techniques. When the majority used the same hand for spear, throwing, tool-making, or ritual gestures, training and imitation became more efficient. Knowledge could be transmitted reliably across generations. This social reinforcement amplified the biological pattern, embedding right-handedness not only in the body but also in culture. Yet culture also marginalized left-handed individuals. In many ancient societies, left-handedness was associated with deviation, unpredictability, or even danger. Rituals, religious texts, and language reflected this bias. The Latin word, sinister, originally meant left, but evolved to imply evil or ill omen. Similar linguistic patterns exist across cultures in Greek, Hebrew, and early European languages. Left often carried negative connotations, while right conveyed correctness, honor, and trust. These cultural associations reinforced the biological majority, making right-handedness not only practical but socially desirable. Despite this cultural pressure, left-handedness endured. Children born with left-hand preference were forced to adapt to a right-hand dominant environment. Tools were designed for the majority. Writing systems favored right-hand strokes, and social expectations discouraged left-hand use, yet left-handed individuals adapted, many became ambidextrous, mastering both hands to navigate a world built against them. This adaptation enhanced neural connectivity, fostering cognitive flexibility. Those who faced constraints often developed acute spatial awareness, problem-solving skills, and innovative thinking. What might have seemed like a disadvantage in infancy, became a subtle advantage in adulthood. The persistence of left-handedness highlights a fundamental principle of evolution: diversity is survival. Groups with variation are more resilient, more adaptable, and more capable of facing novel challenges. Right-handedness promotes stability, coordination and predictability. Left-handedness introduces flexibility, unpredictability, and innovation. Together, they form a dynamic equilibrium that has allowed humans to thrive across diverse environments, from ice-covered plains to tropical forests, from hunting grounds to agricultural villages. Early humans did not merely survive with their hands, they shaped the world through them. Tools, weapons, and artistic creations required skill, precision, and coordination. The majority hand dictated standard techniques, but minority hands often forced creative solutions. Archaeological studies reveal that left-handed toolmakers frequently altered standard methods to suit their dominant side, sometimes producing designs that were more efficient or adaptable. Innovation, it seems, often arises not from conformity but from necessity, an insight repeated throughout human history. Handedness also influenced social dynamics. Groups unconsciously preferred individuals whose gestures and movements aligned with the majority. Right-handed individuals moved predictably. They reinforced coordination and trust. Left-handed individuals, while sometimes viewed as unconventional, could excel in tasks requiring flexibility or surprise. In competitive situations, whether hunting, combat, or negotiation, the minority could wield advantage precisely because they operated outside the expected pattern. This subtle balance between majority conformity and minority innovation has been a defining feature of human societies. The development of language may also have been influenced by handedness. The left hemisphere, dominant in right-handed individuals, specializes in sequential processing, grammar and structured communication. This aligns with social needs for clarity, coordination and teaching. Left-handed individuals, with more bilateral or variable hemispheric engagement, may have processed language differently, integrating visual, spatial, and emotional cues. This neurological diversity could have contributed to early storytelling, metaphor, and symbolic thought. The interaction between biology and culture shaped not only survival but also the cognitive landscape of humanity. As civilizations emerged, handedness became embedded in technology, education, and ritual. Writing systems, from cuneiform tablets to hieroglyphs to alphabetic scripts, favored right-handed execution. Instruments, from plows to musical devices to weapons, were designed for the majority hand. Religious ceremonies codified hand usage in gestures, blessings and offerings. Children were trained to conform, and deviations were corrected. Yet even under these pressures, left-handedness persisted, demonstrating the resilience of biological diversity. The survival and adaptation of left-handed individuals reveal a key principle. Evolutionary success is not about uniformity, but about balance. Predictability allows groups to function, unpredictability allows them to adapt. Majority traits stabilize systems, minority traits safeguard innovation. Right-handedness and left-handedness are complementary, reflecting an ancient balance between cohesion and flexibility, conformity and creativity, and efficiency and adaptability. In the modern world, these ancient patterns remain evident. Despite cultural shifts and technological advancement, approximately 90% of humans are right-handed. Tools, interfaces, and social norms continue to favor the majority. Yet the advantages once associated with left-handedness, in combat, creativity, problem-solving, and adaptation, persist in new forms. Ambidexterity, spatial reasoning, cross-hemispheric integration, and innovative thinking remain hallmarks of minority dominance. The forces that shaped handedness millennia ago continue to shape cognition, culture, and human potential today. In sum, the story of how humans became mostly right-handed is not merely a story about hands. It is a story about survival, evolution, culture, cognition, and society. It illustrates how biology interacts with environment, how culture reinforces biology, and how diversity ensures resilience. It shows that minor differences, like which hand one favors, can ripple through generations, influencing art, technology, learning, and social structure. Right-handedness dominates for efficiency. Left-handedness persists for adaptability. Together, they are a testament to the intricate, dynamic balance that has allowed humanity to survive, innovate, and thrive. Even the simplest daily action, like reaching for a tool, reveals the deep history embedded in the human body. The dominance of the right hand is history, culture, and evolution made visible. The persistence of the left hand is resilience, innovation, and adaptation preserved across generations. Every gesture, every movement, every choice of hand carries the echoes of survival, the imprint of cognition, and the legacy of human ingenuity. From the earliest social groups to complex communities, humans relied on coordination and communication to survive. Right-handedness, already emerging as a majority trait in the first chapter, began to influence not only tool use but social dynamics. In small hunter-gatherer bands, tasks were divided according to skill, strength, and neural wiring. Individuals who were right-handed could synchronize actions with the majority more efficiently. Whether in cooperative hunting, constructing shelters, or transporting resources, this alignment was subtle yet profound. When most individuals used the same hand, teaching and imitation became simpler, mistakes decreased, and the group's overall efficiency improved. In these early societies, trust was built through predictability. Observing a companion grasp a spear, hold a bow, or strike a stone with precision allowed others to anticipate actions. This shared expectation reinforced the dominance of right-handed behavior. Even minor deviations could create confusion, especially in high-stakes situations such as hunting dangerous animals or navigating treacherous terrain. Right-handed dominance, therefore, became both an individual and group-level advantage, supported by neural wiring, environmental demand, and social necessity. However, left-handed individuals, though rare, played crucial complementary roles. Their movements were less predictable, and this unpredictability could be leveraged strategically. In hunting, a left-handed thrower might approach prey from an unexpected angle, giving the group an advantage. In conflict, left-handed warriors could disrupt enemy patterns trained to counter right-handed opponents. Evolution favored this minority, not for quality but for quality. The presence of left-handed individuals preserved adaptability within the population. Diversity in this sense was a form of survival insurance. Archaeological evidence from skeletal remains reinforces this narrative. Bone structure, wear patterns, and tool imprints indicate that right-handed dominance was well established even tens of thousands of years ago. Researchers analyzing fossilized forearms and shoulder joints observed that the majority of hominins had musculoskeletal adaptations consistent with frequent right-hand use. Yet within the same populations, a consistent minority displayed left-hand specialization. This dual pattern, dominant majority and persistent minority, suggests that evolutionary pressures created both stability and flexibility simultaneously. Social hierarchy also intersected with handedness. In early communities, individuals demonstrating skill and reliability were often granted leadership roles. Right-handedness, by aligning with the majority, amplified perceived competence. Gestures, signaling, and physical coordination matched the expectations of the group, reinforcing trust and authority. Leaders whose dominant hand mirrored that of the majority could communicate more effectively, coordinate actions, and maintain cohesion. In contrast, left-handed leaders, while potentially highly capable, faced subtle perceptual challenges. Their movements and gestures could appear unconventional, demanding adaptation from followers. This dynamic is reflected in rituals and symbolic practices. In many ancient cultures, the right hand was associated with blessing, authority, and propriety, while the left hand carried connotations of unpredictability or deviation. Anthropologists note that these symbolic associations were consistent across continents and cultures, suggesting that social interpretation of handedness is deeply embedded in human psychology. Children observe these patterns, internalize them, and learn to conform, further amplifying right hand dominance through cultural reinforcement. Despite cultural pressures, left-handed individuals endured. The necessity of adaptation created unique cognitive advantages. From an early age, left-handed children had to navigate tools, writing, and social expectations designed for right-handed majority. This constant negotiation fostered ambidexterity, spatial reasoning, and problem-solving flexibility. Studies in modern neuropsychology confirm that such adaptation enhances cross-hemispheric communication, allowing left-handed individuals to integrate multiple types of information simultaneously. This neurological diversity proved essential in both individual survival and group resilience. Handedness also influenced learning strategies. Right-handed individuals, aligned with the majority, often excelled in tasks requiring sequential processing, imitation, and structured instruction. Left-handed individuals, by contrast, frequently approached challenges through trial and error, spatial analysis, and lateral thinking. This cognitive variability ensured that early human populations maintained both efficiency and creativity. When predictable tasks were necessary, the majority stabilized the system. When novel solutions were required, the minority provided critical insight. In practical terms, this duality shaped tool making and technology. Stone tools, wooden implements, and early weapons were designed for right-hand use, streamlining production and standardizing function. Left-handed users, however, sometimes innovated alternative techniques to accommodate their dominance. These innovations occasionally improved efficiency, leading to gradual enhancements in design that benefited the entire group. Constraint, paradoxically, became a driver of progress, forcing adaptation and experimentation that might not have occurred in a homogeneous majority population. The pattern extends to communication and gesture. Human societies rely heavily on nonverbal cues. Pointing, signaling, and coordinated movement convey intent, warning, and instruction. When gestures align with majority-handedness, interpretation is rapid and reliable. When they deviate, adaptation is required, and attention increases. This heightened attentiveness, cultivated in left-handed individuals, may have contributed to advanced social perception skills, empathy, and strategic awareness. Those who operate outside majority expectations are often more observant, more flexible, and more capable of navigating complex social environments. Language development is also intertwined with handedness. The left hemisphere, dominant in right-handed individuals, specializes in linear, sequential processing, essential for structured communication. Right-handed individuals excelled in tasks requiring narrative, instruction, and sequential memory. Left-handed individuals, with greater hemispheric interaction, may have developed alternative linguistic skills, metaphor, tonal variation, or contextual inference. These complementary patterns enhanced social cohesion, and allowed populations to innovate linguistically, preserving diversity while maintaining communication efficiency. Over time, as societies grew and specialized, handedness continued to influence social stratification and cultural norms. Tools to education and ritual practice were standardized for the majority, reinforcing right-hand dominance. Yet left-handed individuals contributed disproportionately to innovation, art, and creative problem-solving. Historical evidence suggests that exceptional leaders, artisans, and inventors often emerged from the minority, their skills shaped by adaptation to majority-centered systems. Constraint fostered ingenuity, necessity bred creativity. Even in modern contexts, this ancient balance persists. Right-handed dominance remains evident in tool design, writing systems and social expectations. Left-handedness continues to confer subtle advantages in sports, strategy and creative domains. Neuroplasticity allows individuals to adapt, leveraging both hands and hemispheres for complex problem solving. The forces that shaped handedness millennia ago, biological, environmental, and cultural, still echo in contemporary cognition and social structure. Humans have always been defined by both cooperation and competition. In early communities, every interaction required careful calculation, observation, and adaptability. Handedness, whether one favored the right or left hand, played a subtle but pervasive role in shaping these interactions. Right-handed individuals forming the majority, created predictable patterns in movement, communication, and coordination. This predictability allowed early groups to establish routines, share knowledge efficiently, and maintain social cohesion. When most individuals reached, gestured, or manipulated tools with the same hand, instruction became simpler, errors were minimized, and survival improved. Yet within this structured environment, left-handed individuals persisted. Though fewer in number, their presence introduced variation that the group could not anticipate. In conflict, hunting, or competitive games, left-handedness became a strategic advantage. Opponents trained upon to majority movements faced an unexpected variable. A spear thrown from the left side, a swing from an unusual angle, or a gesture performed contrary to expectation could disrupt coordinated patterns, forcing adaptation. Evolution favored the minority not by quantity but by the ability to exploit the element of surprise. This balance between majority stability and minority unpredictability was central to human survival. Archaeological findings support this narrative. Analysis of skeletal remains, tool marks, and early artwork reveals that right-handed dominance was already established in prehistoric populations. Cave paintings often show right-hand outlines more frequently, while stone tools display wear patterns consistent with right-hand use. Yet consistent traces of left-handed activity appear alongside these artifacts, suggesting that evolution preserved a minority trait for its adaptive value. The ratio, approximately 9 right-handed individuals to every left-handed one, has remained remarkably stable over tens of thousands of years, demonstrating that the forces shaping handedness are both biological and social, persistent yet flexible. Handedness also shaped early social hierarchies. Leaders, warriors, and skilled artisans were often evaluated on their ability to perform predictable, precise actions. Right-handed individuals aligned naturally with the majority, facilitating trust and coordination. Gestures, signals, and movements reinforced authority when they conformed to expected patterns. In contrast, left-handed individuals faced subtle social friction. Their movements, while sometimes more versatile or innovative, appeared unconventional to majority observers. This duality created both challenges and advantages. The minority had to develop adaptability, observation skills, and cognitive flexibility, while the majority relied on uniformity to maintain order. Cultural narratives reinforced these patterns. Across diverse ancient civilizations, the right hand was associated with correctness, authority, and trust, while the left was linked to unpredictability, danger, or deviation. These associations were embedded in ritual, language, and symbolic practice. For example, right-hand gestures were used in blessing, oath-taking, and combat signaling, while the left hand carried metaphorical weight, sometimes negative, sometimes mysterious. Children internalized these norms, learning early that social acceptance depended on conformity. Yet biology persisted, and left-handed individuals continued to emerge, demonstrating the resilience of minority traits in the face of cultural pressure. The persistence of left-handedness had profound implications for skill development. Early tools designed for right-handed majority required left-handed individuals to adapt continuously. Raiding, carving, hunting implements, and musical instruments were all standardized for majority use. Adapting to these tools demanded creativity, problem-solving, and spatial reasoning. Over time, left-handed individuals developed enhanced bilateral coordination, increased neural connectivity, and unique strategies for overcoming physical and social constraints. Constraint, it appears, was a catalyst for cognitive flexibility and innovation. Handedness also influenced learning and communication. Right-handed individuals, with left hemisphere dominance, excelled in sequential tasks, structured instruction, and predictable routines. Left-handed individuals, often displaying more bilateral neural engagement, approached challenges differently. They integrated visual, spatial, and contextual cues, sometimes excelling in tasks that required lateral thinking, pattern recognition, or adaptive problem solving. The result was a complementary cognitive ecosystem. The majority provided efficiency, cohesion, and stability, while the minority contributed creativity, adaptability, and resilience. This dynamic extended into conflict and strategy. In hunting, coordination relied on predictable movement patterns. Right-handed majority ensured smooth teamwork. Yet left-handed individuals, operating outside these patterns, introduced unpredictability that could confer advantage in capturing prey, navigating terrain, or responding to unexpected threats. In combat, the pattern repeated. Left-handed warriors often succeeded not through brute strength, but through unconventional angles, timing, and approach. Evolution had preserved a minority trait precisely because it could disrupt the majority when novelty mattered. Even in creative and technological endeavors, left-handedness played a role. Tool design, construction, and early engineering were optimized for right-handed use. Yet minority adaptation sometimes produced improvements or alternative techniques overlooked by the majority. These innovations, born of necessity, occasionally spread, benefiting entire communities. Creativity often emerges where constraint exists. The need to adapt to majority-centric systems fostered ingenuity and problem-solving skills, demonstrating the deep interplay between biology, environment, and culture. Neuroscience confirms these ancient patterns. Right-handed individuals show left hemisphere dominance for motor coordination and language. Left-handed individuals exhibit more bilateral or variable hemispheric engagement, facilitating integrative thinking, spatial awareness, and flexible problem solving. These neurological patterns reflect evolutionary pressures. Majority dominance ensures predictability, minority persistence safeguards adaptability. Across domains, combat, craftsmanship, communication, and problem solving, the balance between majority and minority has allowed humans to survive and thrive. Cultural evolution also maintained this balance. Societies codified right-hand norms in education, ritual, and design. Writing systems favored right-hand strokes. Tools were standardized, and gestures reinforced social expectations. Left-handed individuals, while often constrained by these norms, developed skills that transcended mere conformity. Ambidexterity, spatial reasoning, and innovative problem-solving became survival advantages in a world that demanded both precision and flexibility. Diversity was and remains a form of resilience. The story of early human social dynamics demonstrates that handedness is not merely physical, it is deeply social and cognitive. Right-handedness stabilized communities, facilitated instruction, and reinforced authority. Left-handedness introduced unpredictability, encouraged adaptation, and fostered creativity. Evolution, environment, and culture acted together, shaping populations in ways both subtle and profound. Handedness became an axis of survival, cognition, and social interaction, embedding itself in every gesture, movement, and tool. Even in daily life, the implications were evident. A right-handed majority could coordinate hunting parties, craft tools, and construct shelters efficiently. Left-handed individuals, by contrast, encountered challenges that required continuous adaptation, observation, and problem-solving. This duality, efficiency and flexibility, conformity and innovation, became the hallmark of human success. Evolution preserved both. ensuring that populations were neither too rigid nor too chaotic, but balanced and resilient. Language, education, art and ritual all reflect this underlying pattern. Right-handed gestures facilitated communication, synchronized action, and reinforced social cohesion. Left-handed movements, though rare, introduced variation, forcing groups to adapt, observe, and innovate. Artifacts from tools to cave paintings reveal this duality. The majority hand dominates in frequency and pattern, while the minority hand contributes innovation and novelty. Together, they shape the trajectory of culture, cognition and human development. Handedness is therefore more than a simple preference. It is a living record of human adaptation, a lens through which we can understand social structure, cognition, and evolutionary strategy. Right-handed dominance ensured cohesion, left-handed persistence safeguarded flexibility. Together, they formed a complementary system that allowed humans to navigate the unpredictable challenges of survival, culture, and thought. The story of our hands is, in essence, the story of humanity itself. As humans moved from scattered bands to structured communities, the influence of handedness extended far beyond the physical act of grasping or striking. Every action, from shaping tools to performing rituals, carried subtle social, cognitive, and cultural consequences. Right-handedness, already established as the majority trait, became a central feature in the coordination of early societies. Individuals naturally aligned their movements, gestures, and techniques with the majority, reinforcing cohesion and predictability. This predictability was crucial in tasks that demanded precision, whether hunting collectively, building shelters, or distributing resources. When nearly every member of a group shared the same hand preference, knowledge transfer became more reliable, reducing mistakes and enhancing survival. Yet left-handed individuals persisted, and their minority presence shaped social dynamics in unexpected ways. In activities requiring flexibility or unpredictability, such as competitive hunting or early conflict scenarios, left-handed movement introduced an element of novelty. Their actions could disrupt established patterns, forcing both peers and competitors to adapt quickly. Evolution preserved this trait because variability is critical in survival. Predictability stabilizes a group, but a small degree of unpredictability allows innovation, adaptation, and the exploitation of unforeseen opportunities. Left-handedness provided this adaptive edge repeatedly throughout human history. Evidence from the archaeological record reinforces the longevity of these patterns. Prehistoric cave art, for instance, demonstrates a dominant right-hand bias but also reveals consistent traces of left-hand activity. Stone tools show where patterns reflecting right-hand use in the majority of cases, yet occasional tools indicate left-hand manipulation. These artifacts suggest that while society favored the majority, left-handed individuals were a persistent minority, contributing in ways that may have been overlooked but were no less significant. The balance of majority and minority, efficiency and adaptability, was a central feature of early human evolution. Social hierarchies were subtly influenced by handedness. Leaders, elders, and skilled artisans were often those whose actions aligned with group expectations. Right-handed movements reinforced trust, coordination, and predictability, establishing authority within the community. Conversely, left-handed individuals had to navigate these social structures carefully, often developing heightened observation skills and cognitive flexibility. The necessity of adaptation honed abilities in problem-solving, strategic thinking, and innovation, allowing minority individuals to occasionally rise to positions of influence despite operating outside majority norms. Cultural beliefs amplified these tendencies. Across early civilizations, the right hand became a symbol of trust, correctness, and social approval, while the left hand was associated with deviation, unpredictability, or danger. Rituals, religious practices, and symbolic gestures consistently reflected this bias. Children learned from a young age that conformity to right-hand norms was socially desirable. Yet biology could not be overridden entirely. Left-handed individuals continued to emerge, demonstrating resilience and adaptability. Their persistence illustrates a fundamental evolutionary principle. Diversity is preserved because it provides populations with adaptive flexibility. Handedness also influenced learning and skill development. Tools, weapons, and implements were primarily designed for right-handed use, requiring left-handed adapt continuously. Writing, carving, hunting, and construction demanded modification of standard techniques. This necessity encouraged creative thinking and spatial reasoning, often resulting in unique problem-solving strategies. Over generations, left-handed individuals developed enhanced bilateral coordination and neural integration, traits that conferred advantages in complex cognitive tasks. Constraint, in this sense, became a driver of intellectual and practical innovation. Cognitive differences between right and left-handed individuals further illuminate this dynamic. Right-handed individuals, predominantly left-brain dominant, excelled in linear processing, sequential reasoning, and structured tasks. Left-handed individuals often exhibiting more bilateral or right hemisphere engagement, integrated spatial, emotional, and holistic information more readily. This neurodiversity created complementary cognitive strengths within communities. The majority stabilized operations through predictability, while the minority introduced flexible adaptive, and often creative problem-solving approaches. Together, these patterns enhanced group survival and facilitated innovation. Communication was also shaped by handedness. Gestures, signaling, and coordinated action relied on predictable movements. Right-handed gestures were easily interpreted and aligned with established norms. Left-handed gestures, less predictable, required heightened attention and adaptation from observers, reinforcing social awareness and situational responsiveness. Individuals capable of navigating these differences developed nuanced skills in perception, negotiation, and collaboration. Left-handed minority status, while challenging, fostered social intelligence and adaptability, qualities that proved valuable in evolving human societies. In the realm of tool making, left-handedness sometimes drove technological innovation. Standardized tools favored the majority, but left-handed users occasionally developed alternative approaches to tool manipulation, cutting techniques, or construction methods. These adaptations could improve efficiency, reduce physical strain, or provide novel functionality. Evolution favored this capacity for innovation. Minority traits persisted not only because they were tolerated, but because they occasionally conferred tangible advantages to the group. Constraint fostered ingenuity. Demonstrating a recurring principle throughout human history, limitations drive creative adaptation. Handedness further influenced artistic expression. Early humans left handprints in caves, carved figurines and painted murals. Right-handed majority patterns dominated frequency and execution, yet minority left-handed expressions contributed novel angles, perspectives, and techniques. Artistic variation once again reflects the interplay of conformity and deviation, majority and minority. Cognitive and motor diversity enhanced creativity, enriching cultural heritage, and expanding the toolkit of human expression. The integration of handedness into early social, cultural, and cognitive systems highlights a broader principle: variation ensures resilience. Right-handed dominance provided structure, predictability, and trust within groups. Left-handed persistence preserved flexibility, innovation, and adaptability. Evolution, culture, and cognition operated in tandem, creating a balance that allowed humans to navigate environmental uncertainty, social complexity, and technological challenge. Every tool, gesture, and action was shaped by this dynamic interplay, embedding survival strategies directly into the human body and mind. Even in education and instruction, these patterns persisted. Right-handed individuals conformed naturally to teaching methods, tool orientation, and social expectations. Left-handed individuals faced challenges but developed compensatory skills, ambidexterity, enhanced spatial reasoning, and adaptive problem solving. These adaptations often produced long-term advantages in creativity, innovation, and complex cognition. The pressures of minority status cultivated resilience and cognitive versatility, demonstrating that evolution values diversity as much as efficiency. In conflict and competition, the benefits of minority status were particularly evident. Right-handed majority patterns enabled predictable coordination, but left-handed unpredictability disrupted expectations. In hunting, combat, and games of strategy, minority dominance often conferred tactical advantages. Opponents trained to respond to majority patterns were forced to adapt, giving left-handed individuals disproportionate effectiveness, despite their numerical rarity. Evolution preserved this trait because unpredictability could be decisive in survival-critical scenarios. Cultural reinforcement amplified these patterns. Societies codified right-hand norms in rituals, symbols, and language. Left-handed individuals, while often stigmatized, cultivated compensatory skills that enhanced adaptability, observation, and creative thinking. Across generations, these dynamics contributed to both individual excellence and group resilience. Right-handed conformity stabilized society. Left-handed deviation preserved the potential for innovation and adaptation. Both were essential to the survival and development of human communities. Ultimately, Chapter 4 demonstrates that handedness is far more than a physical trait. It is a lens into human evolution, social organization, cognition, and culture. Right-handedness ensures predictability, cohesion, and trust. Left-handedness introduces flexibility, innovation, and adaptability. Together, they create a dynamic equilibrium, balancing conformity and deviation, stability and resilience, efficiency and creativity. Every gesture, every movement, every tool or action reflects this intricate interplay, tracing back tens of thousands years to the earliest moments of human society. In every human interaction, from cooperative hunting to social negotiation, the imprint of handedness is evident. Right-handed dominance provides coordination. Left-handed persistence safeguards adaptability. The human species thrives because of this balance, demonstrating that survival and progress depend on the coexistence of majority efficiency and minority innovation. Handedness is thus both a physical characteristic and a story of evolution, culture, and cognition intertwined, shaping humanity at every level from the earliest societies to modern life. Humans have always navigated a delicate balance between routine and innovation. In early communities, daily survival required cooperation, but the ability to adapt, improvise, and innovate often determined who thrived and who perished. Handedness played a subtle yet powerful role in this dynamic. Right-handedness, the dominant trait, provided predictability and efficiency. Tasks such as tool making, cooperative hunting, shelter construction, and food preparation relied on precise, coordinated actions. When most individuals used the same hand, teaching, imitation, and synchronization were far more effective. Errors were minimized and survival rates increased, embedding right-handedness as the majority norm. Left-handed individuals, while rare, introduced a counterbalance. Their movements, often unfamiliar to right-handed observers, created unpredictability that could be advantageous in hunting, conflict, or problem solving. A left-handed throw, swing, or gesture disrupted expected patterns, forcing adaptation among peers and competitors. This unpredictability was not a disadvantage. Evolution preserved the minority because novelty and adaptability were critical for long-term survival. The persistence of left-handedness exemplifies how diversity functions as a built-in safeguard against the limitations of uniformity. Evidence from archaeology supports these patterns. Stone tools, weapon fragments, and skeletal remains reveal that right-hand dominance was already established tens of thousands of years ago. Wear patterns on tools, muscle attachments on bones, and cave art hand stencils indicate a majority of right-handed use, yet left-handed imprints consistently appear alongside them. The ratio: approximately 9 right-handed individuals for every left-handed one, has remained remarkably stable, suggesting that evolutionary pressures maintained both majority stability and minority adaptability across millennia. Social structures were subtly shaped by handedness. Leaders, elders, and skilled artisans were often evaluated on their ability to conform to majority norms. Right-handed individuals had the advantage of alignment gestures, signals, and tool usage matched expectations, reinforcing trust and authority. Left-handed individuals faced subtle challenges, often requiring higher levels of observation, strategic thinking, and adaptive behavior. Over time, these pressures fostered cognitive flexibility, problem-solving skills, and innovation, demonstrating that minority traits were preserved because they conferred survival benefits, even in socially constrained contexts. Cultural narratives reinforced these biological tendencies. Across civilizations, the right hand symbolized correctness, trust, and authority, while the left carried connotations of deviation, danger, or unpredictability. Rituals, language, and social expectations codified these biases. Children learned to conform, mimicking the right-hand preference observed in elders and peers. Despite these pressures, left-handed individuals persisted, demonstrating resilience and adaptability. Their survival reveals an essential evolutionary principle: variation within a population enhances flexibility, adaptability, and long-term resilience. Learning and skill development were profoundly influenced by handedness. Tools, implements, and instruments were designed for right-handed use, requiring left-handed individuals to adapt. Writing, carving, and manipulating tools demanded creative problem-solving, spatial reasoning, and fine motor adjustments. Over generations, these adaptations fostered enhanced bilateral coordination, increased neural connectivity, and cognitive flexibility. Constraint, far from being a limitation, became a catalyst for innovation. Left-handed individuals develop unique strategies, often approaching tasks from alternative angles, leading to breakthroughs that might not have emerged within a strictly majority-dominant framework. The neurological implications of handedness are equally profound. Right-handed individuals, predominantly left hemisphere dominant, excel in sequential processing, structured problem-solving, and linear communication. Left-handed individuals, with more bilateral or variable hemispheric involvement, integrate emotional and holistic information more readily. This cognitive diversity creates complementary strengths within groups. The majority provides stability and predictability, while the minority contributes flexibility, innovation, and adaptive problem-solving. Evolution has preserved this duality because it enhances collective resilience. In social interactions, handedness also played a subtle role. Gestures, signaling, and coordinated movement rely on predictable patterns. Right-handed gestures are easily interpreted and align with social expectations, reinforcing cohesion and trust. Left-handed gestures, less predictable, require heightened attention from observers, enhancing social awareness, perception, and responsiveness. Individuals capable of navigating these differences often developed advanced observational skills, strategic thinking, and social intelligence. Minority status, while challenging, fostered cognitive and social advantages critical to survival. Handedness influenced creative and technological development as well. Tools, instruments, and construction methods were primarily standardized for right-handed use, yet left-handed individuals occasionally developed alternative techniques. These adaptations often enhanced efficiency or introduced new functionality, benefiting the group as a whole. Innovation, it seems, thrives under constraint. The necessity of adapting to majority-centered systems forced creative problem-solving, leading to improvements in tool-making, construction, and later, artistic expression. Constraint paradoxically fueled progress. Art and symbolism reflect this interplay between majority and minority. Cave paintings, carvings, and decorative tools demonstrate that right-handed patterns dominate in frequency, while left-handed contributions provide variation in angle, perspective, and execution. Left-handed expressions, often unconventional, fostered aesthetic diversity and enhanced cultural richness. Cognitive diversity expressed through handedness became a vehicle for cultural evolution, demonstrating the inseparable link between motor preference, creativity and human expression. Even competitive scenarios, from hunting to early warfare, reveal the adaptive advantages of minority dominance. Right-handed majority movements facilitated coordination, yet left-handed unpredictability created tactical advantages. Opponents trained to counter majority patterns faced unfamiliar trajectories, enhancing the effectiveness of left-handed individuals despite their numerical rarity. Evolution preserved this trait because unpredictability could decisively influence survival and success in high-stakes environments. Minority dominance ensured flexibility in response to challenges and threats. Education and skill transmission were similarly influenced. Right-handed learners conformed naturally to majority-centered tools and teaching methods. Left-handed learners, by contrast, encountered challenges requiring creativity, adaptation, and spatial reasoning. These pressures produced compensatory abilities, enhancing cognitive flexibility, problem-solving, and innovative thinking. Left-handed minority status, once a potential disadvantage, became a driver of intellectual and practical development, demonstrating the evolutionary value of variation within a population. Ultimately, the dynamics of handedness reveal a fundamental principle. Survival and progress depend on balance. Right-handedness ensures coordination, predictability, and social cohesion. Left-handedness introduces flexibility, adaptability, and innovative potential. Both are necessary for thriving in complex environments. Evolution, culture, and cognition intersect through this lens, shaping human behavior, social structures, and technological advancement. Every action, gesture, and tool reflects the interplay between conformity and deviation, majority and minority, efficiency and adaptability. Even the simplest daily action, reaching for a tool, gesturing in communication, or crafting an object, carries the legacy of this evolutionary balance. Right-handed dominance stabilizes social and technological systems, while left-handed persistence safeguards adaptability and innovation. Humanity's resilience, creativity, and survival have depended on the coexistence of these complementary traits for tens of thousands of years. Handedness, far from trivial, is a living record of evolution, cognition, and culture intertwined, shaping every aspect of human existence. Chapter 5 underscores that variation is not a flaw but a strategic necessity. Right-handed majority provides efficiency, left-handed minority provides flexibility. Survival and innovation depend on both. This interplay between conformity and adaptation, predictability and novelty, has allowed humans to navigate environmental uncertainty, social complexity, and technological challenge for millennia. Handedness as a window into these dynamics reveals the intricate balance that defines humanity itself. The evolution of human-handedness is a story written not only in bones and muscles, but also in the subtle rhythms of daily life, social structures, and survival strategies. By the time early communities became more organized, right-handedness had emerged as the dominant pattern, shaping the way humans interacted with tools, each other, and the environment. The majority hand dictated standard practices, from gripping spears and chiseling stones to coordinating movements in group hunting and shelter building. In these contexts, uniformity provided reliability. Right-handed individuals, aligned in movement and expectation, could anticipate each other's actions with precision, minimizing errors in high-stakes situations where mistakes could cost lives. Yet alongside this majority, the left-handed minority persisted, and their existence proved vital. Though fewer in number, left-handed individuals introduced variation, a kind of strategic unpredictability. Their gestures, strikes, and tool manipulations were often unfamiliar to others, creating advantages in hunting, combat, and problem-solving. A left-handed throw, swing, or approach could catch opponents or prey off guard, forcing them to adapt quickly. Evolution, in preserving this minority, recognized the value of flexibility. Predictability ensures stability, but a small amount of unpredictability ensures survival in a dynamic, dangerous world. Archaeological records underscore these dynamics. Fossilized skeletons, wear patterns on tools, and prehistoric art show a clear majority of right-hand dominance while consistently revealing traces of left-hand activity. The hand stencils in caves chisel marks on stone, and the distribution of wear on weapons all point to a persistent minority engaging affected despite being unconventional. The ratio. Approximately 9 right-handed individuals to every left-handed one, has remained strikingly consistent over tens of thousands of years. This balance demonstrates that evolution maintains both cohesion and adaptability simultaneously, favoring neither at the expense of the other. Social hierarchies were closely intertwined with handedness. Leaders and skilled artisans often achieved recognition through predictable, efficient actions. Right-handed individuals naturally aligned with majority expectations, enhancing trust and authority. In contrast, left-handed individuals had to navigate social structures carefully. Their unconventional movements sometimes cause hesitation or distrust in observers, requiring them to develop heightened observational skills, strategic thinking, and adaptability. These pressures fostered cognitive and social competencies that could elevate minority individuals in ways not immediately apparent, demonstrating that minority traits can confer subtle but meaningful advantages. Cultural frameworks reinforced right-hand dominance, shaping social perception and behavior. Across civilizations, the right hand symbolized correctness, morality, and trustworthiness, while the left hand carried associations with deviation, unpredictability, or danger. Rituals, religious practices, and language codified these biases. Children learned from an early age that conformity to right-handed norms was socially desirable, internalizing gestures, writing techniques, and movement patterns. Yet biology persisted, and left-handed individuals continued to emerge, demonstrating resilience and adaptability in the face of cultural constraints. This tension between biological predisposition and cultural expectation shaped both individual development and group evolution. Skill acquisition was deeply influenced by these dynamics. Tools, instruments, and weapons were designed for right-handed users, necessitating creative adaptation from left-handed individuals. Writing systems, carving technique, and tool manipulation all required modification or compensatory strategies. Over generations, left-handed individuals developed enhanced spatial reasoning, ambidexterity, and problem-solving flexibility. The constraints imposed by a majority-centered environment catalyzed cognitive development, demonstrating that minority traits can foster innovation and intellectual growth in ways that pure conformity does not. Neurological patterns offer insight into why handedness is so consequential. Right-handed individuals typically exhibit left hemisphere dominance, excelling in linear processing, sequential tasks, and structured problem solving. Left-handed individuals, often showing more bilateral or right hemisphere engagement, are adept at integrating spatial, visual, and contextual information. This cognitive diversity ensures that populations possess both stability and flexibility. The majority maintains order and predictability, while the minority introduces novelty and adaptability. Evolution has maintained this duality because it enhances the long-term resilience and creative capacity of human groups. In social coordination, handedness influenced communication, observation, and cooperation. Gestures, signals, and coordinated movement relied on majority-aligned patterns. Right-handed gestures were quickly recognized and accurately interpreted, reinforcing cohesion and mutual understanding. Left-handed gestures, less predictable, required increased attention and adaptation from others, fostering acute social awareness, perceptual acuity, and flexibility in interpretation. Individuals capable of navigating these differences developed sophisticated social skills, strategic thinking, and the ability to anticipate alternative actions, capacities that proved advantageous in both cooperative and competitive scenarios. Technological innovation was also shaped by handedness. Standardized tools and instruments favored right-handed execution, but minority left-handed users occasionally introduced new methods or improvements. Alternative techniques for carving, shaping, or constructing often enhanced efficiency or reduced physical strain. These innovations, born of necessity, sometimes spread through communities, illustrating a key principle: constraint often drives creativity. Left-handed individuals, adapting to a world designed for the majority, frequently contributed to technological and practical advancement in ways that might have gone unnoticed without their minority perspective. Art and symbolic expression provide further evidence of the interplay between majority and minority dominance. Cave paintings, carved figurines, and other artifacts overwhelmingly reflect right-hand majority patterns, yet minority contributions appear consistently in unconventional angles, perspectives, or execution. Left-handed artistic expression enriched cultural heritage, introducing variation and encouraging experimentation. Cognitive diversity manifested in motor preference not only shaped functional skills but also aesthetic sensibilities, demonstrating that adaptation and deviation can enhance creativity and cultural richness. Competition and strategic interaction consistently reveal the advantages of minority dominance. Right-handed majority patterns facilitated coordination and predictability, yet left-handed unpredictability created tactical leverage. In hunting, combat, and games of skill or strategy, opponents trained to anticipate majority movements were often challenged by the unexpected. Left-handed individuals, though few in number, could achieve disproportionate success by exploiting their difference. Evolution preserved this minority precisely because flexibility and novelty often determined survival when routine patterns failed. Education and knowledge transmission were also influenced by handedness. Right-handed learners could conform naturally to majority-oriented tools, teaching methods, and social expectations. Left-handed learners, however, were compelled to adapt continuously. This necessity fostered compensatory skills such as enhanced spatial reasoning, ambidexterity, and adaptive problem solving. Left-handed minority status, once a potential disadvantage, became a source of intellectual growth and practical ingenuity, demonstrating the evolutionary advantage of maintaining diversity within populations. Ultimately, the story of Chapter 6 emphasizes that handedness is more than a physical characteristic. It is a lens through which we can understand evolution, social organization, cognition, and cultural development. Right-handed dominance stabilizes systems, enabling coordination, learning, and social trust. Left-handed persistence preserves adaptability, innovation, and resilience. Both traits are essential, reflecting a balance between predictability and flexibility that has allowed humans to survive and flourish in complex, changing environments. Every gesture, every movement, every tool or action embodies this intricate interplay, tracing back to the earliest stages of human society, and continuing to influence behavior and culture today. Even the simplest daily action, like reaching for a tool, crafting an object, or communicating a gesture, carries the imprint of this evolutionary balance. Right-handed dominance reinforces cohesion and efficiency, while left-handed persistence ensures adaptability and innovation. Humanity's ability to thrive in varied environments, solve novel problems, and develop complex societies depends on the coexistence of these complementary traits. Handedness is, therefore, not trivial. It is a living record of human evolution, cognition, and culture. Humans are defined not only by their actions but also by the patterns of their behavior over generations. Handedness, though often overlooked as a simple preference, has shaped the trajectory of human evolution, social organization, and cultural development. Right-handedness, dominant in the majority, provided predictability that was essential for survival. Early communities depended on coordinated action in hunting, gathering, and tool making. When most individuals shared the same hand preference, movements became standardized, instructions were easier to follow, and errors decreased. In high-risk scenarios, such as hunting large game or defending against predators, this predictability could mean a difference between life and death. The left-handed minority introduced a counterbalance that was equally vital. Though less numerous, left-handed individuals brought unpredictability into everyday activities. Their gestures, strikes and tool manipulation often deviated from expected patterns, creating advantages in combat, hunting and problem-solving. A left-handed throw, for example, could take opponents or prey by surprise, forcing adaptation. Evolution preserved lettedness not by chance but because diversity enhances survival. Predictability ensures stability, but flexibility ensures adaptability, and minority dominance fulfills this critical role within human populations. Archaeological evidence underscores the long-standing nature of these dynamics. Fossilized skeletons reveal muscle attachments consistent with right-hand dominance in the majority of individuals, while wear patterns on tools and weapons indicate consistent left-hand activity in a smaller subset of the population. Cave paintings and hand stencils show the prevalence of right-hand use but also reveal minority expressions through alternative angles or non-dominant hand markings. The ratio of approximately 9 right-handed individuals to 1 left-handed individual has been maintained across tens of thousands of years, suggesting that evolutionary pressures, cultural norms, and environmental demands work together to preserve both majority efficiency and minority adaptability. Social hierarchies and leadership were influenced by handedness. Leaders, elders, and skilled artisans were often evaluated based on their ability to perform predictable, reliable actions. Right-handed individuals naturally conformed to majority expectations, reinforcing trust, authority, and coordination. Left-handed individuals, by contrast, had to navigate social systems carefully, often developing heightened observational skills, strategic thinking, and adaptability. These abilities allowed some minority individuals to rise to positions of influence despite their unconventional movements. Left-handedness, therefore, was not simply a physical trait but a driver of cognitive flexibility and social intelligence, crucial for navigating complex early societies. Cultural perceptions reinforced these dynamics. Across civilizations, the right hand was associated with correctness, trust, and moral authority, while the left hand was often linked to unpredictability, danger, or deviation. Rituals, religious ceremonies, and language codified these associations. Children learned early that right-hand use was socially desirable, internalizing norms that shaped gestures, tool use, and interaction patterns. Yet biology persisted, and left-handed individuals continued to appear across generations, demonstrating resilience and adaptability in the face of cultural pressure. Evolution favored the coexistence of majority and minority traits, because it balanced conformity with innovation. Skill development and learning were also shaped by handedness. Tools, weapons, and instruments were designed for right-handed users, requiring left-handed individuals to adapt creatively. Writing, carving, and manipulating tools demanded spatial reasoning, problem-solving, and compensatory motor skills. Over time, these adaptations enhanced bilateral coordination, neural connectivity, and cognitive flexibility. Left-handed individuals often approached problems from novel angles, producing solutions that might not have emerged within strictly majority-oriented systems. Constraint, far from being a limitation, became a catalyst for innovation, fostering intellectual and practical development. Neurological patterns reveal the deeper reasons behind these differences. Right-handed individuals, predominantly left-hemisphere dominant, excel in linear processing, sequential thinking, and structured communication. Left-handed individuals, often exhibiting more bilateral or right-hemisphere engagement, integrate spatial, contextual, and emotional information more readily. This neurodiversity ensures that populations retain both stability and adaptability. Majority patterns maintain predictability and coordination, while minority patterns introduce flexibility and innovation. Evolution preserved this duality because it enhances the resilience and problem-solving capacity of human groups. Communication, coordination, and social perception were also shaped by handedness. Gestures, signals, and cooperative movements relied on predictable right-hand patterns for clarity and efficiency. Left-handed gestures, less familiar to observers, required heightened attention, reinforcing observational skills, strategic thinking, and social awareness. Individuals adept at navigating these differences developed sophisticated problem-solving abilities and enhanced social cognition, skills that proved critical in both cooperative and competitive contexts. Minority dominance, though numerically small, often had outsized influence in shaping group dynamics and adaptive strategies. Technological development was profoundly influenced by this interplay. Standardized tools, instruments and construction methods favored right-hand use, streamlining production and increasing efficiency. Left-handed individuals, constrained by majority-oriented tools, often devised alternative approaches that improved function, efficiency, or ergonomics. These innovations, born of necessity, demonstrate how minority perspectives can drive progress and adaptation. Left-handedness, therefore, was not merely a biological curiosity but a source of creative problem-solving that advanced the capabilities of early societies. Art and cultural expression reflect the contributions of both majority and minority hands. Cave paintings, carvings, and early decorative objects display a preponderance of right-handed execution, yet minority left-hand imprints reveal innovation, alternative perspective, and experimental approaches. These contributions enriched cultural expression, demonstrating that variation in handedness enhances both functional and aesthetic domains. Cognitive diversity, manifested in motor preference, became a driver of creativity and cultural richness, showing that adaptation and deviation were essential for progress. Competition and strategic interaction consistently highlight the advantages of minority dominance. Right-handed majority movements facilitated predictable coordination, yet left-handed unpredictability created tactical advantages. In hunting, combat, and problem-solving, opponents accustomed to majority patterns faced challenges from unexpected left-handed actions. Despite their numerical minority, left-handed individuals often achieved disproportionate effectiveness, demonstrating that evolutionary persistence of minority traits is linked to their adaptive potential. Variation within populations is not merely tolerated, it is preserved because it enhances survival and long-term resilience. Education, apprenticeship, and knowledge transfer also reflect handedness dynamics. Right-handed learners conformed naturally to majority-centered teaching methods, tools, and social expectations. Left-handed learners, encountering challenges, developed compensatory abilities such as ambidexterity, spatial reasoning, and adaptive problem-solving. These adaptations frequently produced cognitive advantages, allowing minority individuals to approach complex problems with novel strategies. Evolution maintained diversity within populations because minority traits fostered skills critical for innovation, creativity, and problem-solving. Even the simplest daily action, such as grasping a tool, crafting an object, or gesturing during communication, reflects this evolutionary balance. Right-handed dominance stabilizes social and functional systems, while left-handed persistence safeguards adaptability and fosters innovation. Human resilience, creativity, and ability to navigate complex environments depend on the coexistence of these complementary traits. Handedness is therefore both a physical trait and a living record of cognitive, social, and cultural evolution.